So let's see how we solve this problem 9. As usual, the first step is to change the integrand into variable z. So we'll say, let solution, let I be the given integral from 0 to 2 pi of cosine of 3 theta divided by 5 minus 4 cos of theta d theta. So let's call that one I. Then let's now convert this I into general integral involving both the complex and the involving both the real and the imaginary part. So we'll say I is the real part of the integral 0 to 2 pi. Then we first complex term this integrand. So we'll have cosine of 3 theta plus I sine 3 theta 5 minus 4 cos of theta d theta. From Euler's identity, this can be written as the real part of 0 to 2 pi. Now by Euler's identity, the numerator will be e raised to power 3 theta I over 5 minus 4 cos theta d theta. So with that, then convert cosine into exponential. So we say I will be the real part of the integral 0 to 2 pi and then e raised to power 3 theta I 5 minus 4 cosine is given by e raised to power I theta plus e raised to power minus I theta. We divide by 2 and then d theta. So in simplification, this will give us I is equals to real part of the integral 0 to 2 pi of e raised to power 3 theta I 5. Now these two, divide these 2 times, so minus 2 e raised to power I theta minus 2 e raised to power minus I theta d theta. Now let's now introduce the z variable. So say let z be given by e raised to power theta I. So it implies e raised to power 3 theta I will be z cubed. The theta, you can always show that is given by I, is dz over iz. And when you say e raised to power minus I theta, you get it as 1 over z. So with the new variable z, then you now change the structure of the integral. Now it turns out into the contour integral. So I will be the real part of now the contour integral e raised to power 3 theta I z cubed, and then this will be 5 minus 2z minus 2 over z, then you multiply by the z over I z, that's the value of the theta. When doing that, I will be the real part of, now you can write this one along C, then you write this one dz over I, so multiply z by every term, so we have 5z minus 2z squared minus 2, and then we have z power 3. So this we can write it as I is the real part of the integral along C. I can factor out negative here, say negative 1 into 2z squared, now minus 5z plus 2, and then this is z power 3 dz over I. So it's like I have, for this a product, I can delete this one and write that negative sign at this point. So I'll multiply by I and I multiply by I to remove this I term in the denominator. So this means my I will be real part of contour integral. So z cubed I. Now this will give me 1. So 2z squared minus 5z plus 2 dz. So now this quadratic part, 2z squared plus minus 5z plus 2, product is 4, sum is minus 5. So numbers should be negative 1, negative 4. So 2z squared minus z minus 4z plus 2. So this part, z equals z into 2z minus 1 minus 2 into 2z minus 1. So which will be z minus 2 and then 2z minus 1. So it means that you can write this quadratic expression as a product of these linear terms. So i.e. I is the real part of the integral z cubed over z minus 2 times 2z minus 1 dz. That's what we have by definition. That's minus 1. Now, there's an I here. So we can say here, let f of z to be z cubed I over z minus 2, 2z minus 1. Immediately identify f of z, then go to the process of finding poles. And poles are, you take the denominator, you equate to 0 and solve. I.e. z equals to 2 and z equals to a half are the poles of the function f of z. Now, of these two poles, only z equals to a half lies within the unit circle, and actually that's what we use to find residue and the solution to the problem. So residue at z equals to a half, by definition, is limit as z approaches a half, z minus a half, multiplied by f of z. Which will be the same as limit as z approaches a half, z minus a half, times f of z is z cubed I. Remember at this point here, this is our f of z, over z minus 2, 2z minus 1. You see, we can write this one as limit as z approaches a half, and then you write z minus a half multiplied by z cubed times I. Now the denominator, so that I have this factor, using this second term, I write 2 outside, then z minus a half. So this is the same as what we have as the second bracket, then z minus 2. Immediately we do that, we now do some crossing. So this bracket and this bracket cancels out. So I'll have limit as z approaches a half of z cubed I over 2 into z minus 2, which will be a half cubed I over 2 into a half minus 2. Half cubed is 1/8. So a half minus 2 times 2 is minus 3. 1/8 divide minus 3 is minus 1/24. I. Then by Cauchy residue theorem, integral along C of f of z dz is 2 pi I times sum of residues within C. But because it's just 1 for our case, we'll have 2 pi I times negative 1/24 I. And you see, negative I times I is 1. This is the same as 24 pi, 2 pi over 24, which is the same as pi over 12, which is purely real. Hence, the given integral from 0 to 2 pi of cos of 3 theta divided by 5 minus 4 cos theta d theta is nothing but pi over 12, as we have seen at this point. So this is how we are to argue the solution to the given problem. Thank you.